Hello. Welcome to the stream. Variety streaming on a Sunday to mix it up. Much like I streamed last night to mix it up. For those of you who've missed the recent streams, on Saturday morning we streamed a bit and got texture assignment working. We now write out, so in the Voxel engine, we build a big 256 by 256 by 1024 grid of 32-bit numbers and populate those with the texture request specified in the command lists. And then when we build the meshes, we read from that. The performance on that is okay because it's a write-only pass during the command list processing. And then last night, I got the interior versus exterior working, which is just that when you draw a slab, if you think of it as a cube, the edges of the cube, the voxels along those edges, get a different texel assignment than everything else. Which is just because then, like when you're drawing a wall, which is like a cube that's one thick on one axis, one voxel thick on one axis, when you're drawing that wall, that then means that the frame of that rectangle that you're building gets one texture assignment, and then the interior gets a different assignment. And the normal use for that is to actually make the visible faces all the same, but it allows you to make interior faces different, which lets you punch holes for windows and get a different texture from them. So got that working last night, and also command list culling had gotten a little inefficient because we were now using pretty big command lists. So we changed it so that command lists get parallelized across each command in the command list instead of a single SIMD lane running through the entire command list and culling it. Instead, a work group handles an 8x8 region and parallelizes the like 32 or 64 command list entries in parallel and decides which ones can be culled and writes them out. And there's a bit of a hack there, which is this unreliable ordering, which is that we just write them out in all the lanes right in parallel, and the way they pick where to write is with an atomic append using atomic add, and this is not guaranteed to be in lane order, and it needs to be in lane order to preserve the order of the command list. And that's because the unreliable ordering, if I disable unreliable ordering, it tries to use this thing that we wrote that uses ballad arb and its own effective prefix to do the ordering correctly, and it's not working for some reason, and I didn't feel like figuring it out. And I'm still going to leave that alone for now. So that's a review of where we were, where we are. So previously, we had this idea for the command lists of update texture, that you could have a command in the command list that changes the texture data without changing the occupancy. And in the end, I decided that the problem is that requires like a read, modify, write. You have to read the existing texture data and overwrite it, because the idea is you could set only one side. The idea is that like you maybe want to put decoration on the wall, and it's the interior, and you don't want to keep track of exactly what's on the exterior of that same wall, because maybe there's trim has been applied selectively in various patterns on the outside, and you don't want to have to figure that out. But the problem is that if we're encoding the textures in a kind of a subtle way, then even with a read, modify, write, there may be no way to encode an extra texture, a new texture on one face. So I set that aside. 1 second, I'll be right back. But I was thinking about trim. I can answer this question probably that was directed at chat. When you say you're looking at the command list type of pattern, so that it is not normal to use command lists in modern graphics programming. Under the hood, the GPU and driver may be communicating using command lists. The driver generates command lists that it sends to the GPU. For example, issue this draw call, clear the frame buffer, etc. But it's not normal when doing graphics work to know about that. That's hidden under the hood, and we're only doing command lists here because we're doing compute shaders and we're not using the graphics pipeline. And so this happens to be the pattern that is useful, that I decided arbitrarily to use to do this. It's a very old pattern. For example, the old vector graphics games. So, for example, this vector graphics game works by the CPU produces a list of all of the line segments that it wants to draw, and it sticks them into a big command list buffer. And then a coprocessor in the arcade machine reads from that list and reads out, you want a dot here, or you want a line segment, line segment, line segment, line segment, line segment. So it's just a metaphor for communication between things. Like, you don't have to think of that as a command list. You could just think of it as like a list of segments to draw or something like that. Normally, command list kind of implies a sort of imperative: do this, do that, and that there's some heterogeneity of what's being drawn or being done, I think. Okay. So, anyway, I was thinking, setting aside this texturing thing, what might be nice to do is when drawing trim on a building, like maybe we want to, like, put lines, a horizontal line between floors or in some kind of pattern, or outline a window. And at the moment, we have to do that with textures, and we can't really think about colors. We have to say, well, what's an appropriate texture? Or we kind of ignore what's actually in the texture and just say, well, what's a good looking color for it? Like sometimes people do that in Minecraft. They build stuff basically just using the color of the block without worrying about what it's supposed to be semantically. And so I was thinking that, and thinking, well, a thing that you can do, which I do in STB Voxel render, is you can apply a color as well as texture. So we could have the ability to have a color recolor the voxel. And again, voxels can be on the border of a building and be both the interior and the exterior. So you don't really want to color the whole voxel. You want to like apply the coloring pattern to the exterior. So you want to really be able to do it on a single side at a time. So that's a lot of extra data. We are already there's a fifth number that's been added. So if you look at meshing, the first number is the occupancy, second number is visibility, third number is computing just the raw texture data, and the fourth number is meshing, turning it into triangles. And so we're already up at 0.30, and so if we were writing out a color data as well, that 0.30 like doubles if you write out another 32-bit word. And so it's hard to see how we can write out a color per face and really have acceptable performance, and we would still have the read, modify, write problem. And we can compact the colors down. We could have only 8 bits of color with some kind of color palette, and that would be plenty for the kind of coloring that we're trying to do. We don't need to do smooth gradients. And maybe you could pack it down to 6 bits. So at 5 bits, you could fit it into 32 bits. But so what I decided to do was, what if we have an auxiliary data structure that just says whether or not a given voxel has color data, because let's assume it's rare. And so like a 1 byte flag for whether we have color data. And so I tried, when we generate the texture grid, I experimented with storing to a 1 byte texture a flag basically every time, zeroing it, because we need to zero that data. We don't worry about zeroing the texture grid because we know we're only going to read the texture grid where we have an occupied, we have to have a visible voxel. So we know that the voxel is occupied, so we know if we just write out a texture for every occupied voxel that we're guaranteed to have the texture data we need at read time. But if we want to have this optional data, we need to zero it. And so I tried zeroing it here. So you can see, like, I tried, maybe I have 2 colors and I zero them. And that was it was a significant added time. I don't remember what it was. And I tried just adding this, storing 1 byte. and that still bumped it up from like 0.30 to 0.40. I forget now. So then I decided what we can do is store 1 bit instead of 1 byte. So if we store 1 bit per thing, then we can just, and then it's a lot smaller of a data structure, and we can just clear it. And so that's in this code, the 5th number on the mesh data is the clearing of the 1 bit per voxel data structure. So it's 0.02 milliseconds. So that's much smaller time. So if we don't use this feature, we're paying that 0.02 milliseconds, and then we'll have to read it. And then the idea is that you can do an atomic OR to update it to indicate that you have data there. And you can see our time went up. The 3rd number in meshing went from 0.30 to 0.50, basically, 0.48. Because we're doing it on every voxel. But the idea is if you only did it very sparsely on a few voxels, you'll only pay that cost on the voxels that use it. So that's a little bit of work that I did, basically measuring the costs. I accidentally left OBS running, the OBS that does the projector. So I was paying the OBS overhead, so I don't know what the cost is without the OBS overhead. So one thing we did last night, to get the command list culling parallel of the list entries is we made sure all of the list entries are the same size. Which this is wrong. I plus equals 3. Oh, because we added 1 to I here. Yeah. Where does command slab? Oh, I plus plus, I plus plus, I plus plus. It's not being done here, but in other code. Yeah, we just share the erase and slide code right now so that they do the same thing. So I made all the commands be the same size, because then the culling can work in parallel and just compute where the command starts in memory without having to incrementally read all of the intervening variable length commands. But I was thinking about that, and there is a command that we want to have that's different, that has to be different sized. So we can't do it that way. So what we have to do is switch to I think what we're going to do is add an indirection, and we're going to store the address, the offset of all the commands, followed by the actual commands. So we're going to do that first. That's our first project. Why did I leave Epic? I wasn't doing good work there. I don't belong in a big company. I should have just quit as soon as we got acquired. I didn't really work on Fortnite or on Unreal Engine Core. I was still continuing doing rad projects. That's the only reason I didn't quit right immediately. We'll start with main. So what we want to do is we're going to output the address of each command. How do we want to do this? Count is the number of commands we've done. So we can unit base So P becomes an offset from base. And then base of count, 1 plus count is P. Count is the number of commands we've output so far. So it, for example, starts at 0. So base of 0 is going to be the count of the commands, and the base of 1, base of 2, base of 3 is the offset to the command. And then P needs to start, I don't know, how many commands do we have? We have 50 floors, 60 floors, have maybe 10 windows on each floor, 10 on each side, so that's like 40 times 60, what, 2400? So are we running 2400 commands already? Crazy. So P is going to start at say 16384. Sure. And then let's make sure command list is big enough. Command list is 4 megabytes. Just to be explicit about how much storage we're storing at the beginning. This is just P now. And then the color needs to parse that, but we can make it, the color can output directly the old format. So we'll save that for now. Okay, so in the color, we can actually change this to be uint command count uint except this always makes the compiler get slow. Command offset. But yeah, that's measured from the beginning of the buffer anyway, so let's not do that. So num commands is command list of 0. Command list of 1 plus slot. Maybe that's all it takes. Eight. What? Oh, 68 isn't the... it looks correct. Okay. What is count? Why are we not hitting that breakpoint? Oh, because we don't rebuild the map. We only rebuild the voxels. Count is 2,000. Okay. So reserving 16,000, sure. But actually, we should check how big is P at this point. So we've output 8,000 words. 35 kilobyte command list so far to generate this data. Okay, so now we can have variable length commands again, and I'm gonna check that in. Okay, so now we can start thinking about having this color data. So what we'll do is we'll do it like the naive version first and then progress to the actual thing we want. So for the naive version, so one of the things is that you want to be able to write this sparse data. So we have this 1-bit value for whether we have info or not has update. Then we're going to have has which update. We'll have 1 byte per voxel. And that's going to store 8 bits that are which of these other things that are below we have. And then these things are in separate 1-bit text, 1 byte or 2 byte textures, so that we can update them independently. So we can update each face independently. And then we'll set a bit in which update for which faces we did. We may or may not need which update. This is what we'll see. So the naive version, we're just going to have all of them. So where do we want to do this? All right, well, so we can do this as part of the texturing pass. However, I think the job usage may not be very efficient for this, because when we have an 8x8 region and we have a trim that's horizontal, it's only going to touch like 8 voxels in that region, and we're going to have 32 lanes trying to process that, so it's only going to hit 25% utilization. So we might want to dice this up a little differently, but for now we'll go ahead and just do it in the build texture grid. So this is going to be define command update recolor. And it's still going to use this same data. So let's make this I plus 0, I plus 1, I plus 2. Maybe it's actually like this. Reuse this code too. So what we're going to say is uint color equals command list plus 1 r plus equals 2. And then if equals command slab, we do this logic, else we set the bit on has update, uint mask equals 1 shift left C F31, uint equals atomic or has update mask if value and mask equals 0. So if the old value for this bit was 0, then we've never written to it before. So we're going to write to it now. And let's just store all of them. Let's store color east. Do I want to make this a 3D texture? I probably want to make this a 3D texture. I just had existing code that could initialize it, the 2D texture, which made it a little simpler. But then we were doing this math to sort of atlas together the Z, and it would just be cleaner if it was a 3D texture. Yeah, let's make it a 3D texture. What is the third? R. Because, yeah, you would be. And then I added these. I copied these in from the old CMC file because we're going to do project. Oh, yeah, so let's talk about that now that we've got enough people here. So this week is going to be Voxel week. This engine has gotten to the point where it's pretty interesting. The performance is okay on this old 980 Ti. So I think we'll spend this week just working on the Voxel engine instead of it being a Friday project. Whether that means we'll flip to this being the main project for the rest of this, for the foreseeable future, I don't know. We also got the train engine to a pretty nice point of the ground morphing really nicely. The next step, the next major step for that terrain project is to build an editor that allows us to merge together chunks of real world data, which I've been kind of putting off, and that was kind of why I did the stream, was hoping that would let me stop putting that off. But because this voxel stuff is now reached an interesting point, it's maybe more compelling to keep working on it. Yeah, graphics programming is just kind of weird. I mentioned that like 10 years ago or something, I sort of was working on a book about making a game, a graphics engine using OpenGL. Sort of trying to teach starting from nothing using OpenGL immediate mode. But the problem is, like, OpenGL immediate mode is so discouraged now. I felt like that wouldn't really be a service to new programmers. It doesn't translate to other engines, to other APIs. And so I killed it. And I'm not sure what exactly you could tutorialize that would be, because I don't want to put the investment into learning Vulkan and having that dealing with the setup for Vulkan. It's such a huge mess. I don't know D3D 11 or 12. I have used D3D 9 a little bit. But those C++ APIs aren't very convenient from VC6. So I don't know. Like, I don't know that teaching OpenGL immediate mode is really the way to go, and I don't think I'd want to do anything other than OpenGL immediate mode. But yeah, and also it's just not clear what the concepts are exactly in graphics programming. It's such an open thing. I mean, I guess that's true for what Casey's doing too. But I mean, the other thing is that Casey is doing that as a business, and also sort of turning into an internet personality, which isn't really interesting to me or appealing to. But I'm going to do some stuff on WooCache. And we'll see how that goes. But anything with Wasabi, I think I used Wasabi for my audio. But I'm not positive. We don't want the cross. We don't want the cross platform. We want the Windows. Where's the Windows? iAudio client VTD. I don't know what API that is. I don't think that's Wasabi. Is it? Oh, is that what? My audio client. This isn't letting me get at the context of what its core audio APIs. It's just the core APIs. Oh, they just don't call it Wasabi here then? Yeah, okay, that is Wasabi. So yeah, I have done it. This is just the whole mess of me not using Windows, so I have to copy all of the Windows.h stuff into my code. Because I'm not using Windows.h for performance compilation performance reasons. So that would be, this is roughly what it would take to get D3D11 working. Yeah, I mean, the thing is, I also don't know D3D11, so I'd be spending all my time looking it up. I mean, I spend a lot of time looking stuff up with OpenGL, but it would be that much worse. So I don't know if that's a good idea. All right, anyway, create texture 3D. So we go back to main, recolor, and now let's try making the speed texture 3D, 236, 236, 1024. Retext. Oh, so retext. So the idea here is that you can assign a color to each of the faces by writing to one of the textures. So for performance reasons, you don't have to write to all of them. And so for textures, I have two 16-bit things, and what you'll store in that is which face and what texture, and it's 16 bits, so that you can pack more than 6 bits of texture data. So you can get, say, 8 or we might as well just do 10. We're going to assume, we're ballpark assuming right now that there are 1,024 textures, in a texture array for the world texturing of the voxels. Some of them will be dedicated to ceilings, some will dedicated to floors, and so in a lot of the encodings, it will know to offset into that array of 1024 because it knows, oh, this is the section where the walls are, so you only store 8 bits and index into the walls from there. But then there's a global ID that's just 10 bits. So what this can do is it can store 10 bits and then a 6-bit mask for which faces it applies to, say. And you can store 2 of them. So you can apply a retexturing on the interior and on the exterior. You would dedicate it that way. You would say 0 is meant for interior walls and 1 is meant for exterior walls. And if you can't use more textures than that. But that's just an arbitrary choice to keep it from being too big. And then the which update is 1 byte per voxel, which gives us 8 bits. So we can set the 6 bits for the recolor and the 2 bits for the retext. And that lets, when we mesh, when we go to do it, we grab the 1 bit from has update for do we have an update, and if that is set, then we can read the 1 byte for which update to determine which bits to read. Then we read from these selectively only if the corresponding bit is set, so that we minimize how much reading we have to do in that meshing step. And the idea, again, is that only a small number of voxels will go through this path. So when a lane hits this stuff and has to read this data, it will stop the entire hyperthread while it waits for the memory read, but another hyperthread can run. So the fact that the utilization may be low should be too bad, I think. And this whole updating the bits of which update is optional. I don't know if that's the right thing to do. Okay, so now this is the 3D texture. So we need to go find where we use it. And we're using bind image texture. Oh, but that does layers. No, but the layers only matters if we do arrays. Okay, so yeah, this is still fine. Yeah, I think that's fine. And then when we use it, these are now 3D. These are 16. Shouldn't this go up to 7? What am I missing? Oh, I dropped U. I can only actually bind 8 of these in this. Oh, I had to bump the version of OpenGL up to 4.4 so that I could do where is it? It's mesh times to 4. Clear. Yeah, clear buffer data. It needs to happen earlier. So this is where we clear the 1 bit per voxel storage using this function called geoclear buffer data, which we saw was taking 0.02 milliseconds. And we're now doing it at the same time that we do this so that we don't have to do an extra shader storage barrier. Sure. Okay, so then back in this, so object3 address is XYZ. Now we just say addra, and we store value, not value, we store recolor. So the interface to image store takes 4 channels, RGBA, even though we're storing to a single channel thing. Just as an API simplification, they just always take a 4 vector. And it just, the compiler knows it's the recolor E is in R8 UI. So it knows it's a red 8 UI, so it knows when it goes to write to that it's, oh right, and this is the path where it's the first time we're writing to this one, so we have to write all the data. Except actually, the whole point is we don't have to do that. We do which update, so we don't have to do all that writing. This lets us do all this lazy sparse writing. I don't think we ever created which update, did we? Right, and because we're already limited, we've run out of slots for this, because this hardware or something limits this to only 8 of those. We'll have to do it. There is an extension that allows this data to be 8-bit. I haven't looked for it. But maybe I should use that. What? I don't even know what to look for. OpenGL extension registry. We'll we'll start here, find the extension, and then that'll tell us the name, and we can go back from that to so we're looking for like types of shader storage. Shader storage short or something. Storage. Don't think that's going to be it. Shader storage buffer object. So that's when they introduced that. Buffer storage. Looks like there's never been an extension for it. So that strategy of finding it through this did not work. Yeah, that's just buffer storage. OBGL wiki buffer shader storage. Yeah, functionally speaking, it's that, which is a reason why you should be able to do byte accesses. Yeah, there's nothing about it here, but I know there was some way. Shader storage buffer, byte access. I hate to look at the AI. Fine, let's see what the AI says. Storage. I was searching for storage. Is it only Vulkan? Is it not in OpenGL? Yeah, I've definitely seen this. This was what I was looking for. It just wasn't in the registry. Written against version 460, so it must be later than 460. So what we want is that type. Maybe it's only an extension. Can we compile? Or can we compile the shader? Not supported. Okay, there you go. So it's probably Vulkan only or something. So anyway, so for that reason, we're storing this as a uint, so it's going to encode 4 voxels worth of data. So when we go to which update, we have to do this addressing manually, and it's z shift right 3 2 z shift right 2 plus. So now z, instead of going from 0 to 1024, goes from 0 to 256. So it's 256 times y times 256 plus x. Mask equals directs ff shift left 8 times z and 3. I guess that doesn't matter because it's part of the shift. So we want to create the mask so that it's just covering one of the 4 bytes. So it's a FF in whichever byte, and then that becomes atomic or which update of slot. Comma mask. That shouldn't do anything because we haven't put any of those in. So there should only be command slabs in the data. Our erase adds 3. If we just do that. Because we did change this, the I plus 0, I plus 1, I plus 2 used to be increments. Used to just be this. Okay, well, I've just totally broken it. So let's copy the old version of the code. And then redo back to the state we were at. And then if 0, if 1, paste, else, new code. Okay, so here's the old code working correctly. And here's the broken new code. So we put this up here, and we compare, and those all look the same. So that should still work. It does. This shouldn't be being triggered, so let's try that. Oh, I see. We redeclared it here. Yep, okay. That'll be what it was. Yep, okay, that was it. Okay, now we're not running any of the new code. It's really cold in here. I'm going to close the window. And then we want to look at what the performance is. .28 milliseconds currently being spent in here. We know that you can't have text 0 and text 1 at the same time as recolor. But the compiler might not be able to figure that out because, you know, they get used here, but then they're both available here, and then they're used in different cases here that again matches the exact same thing. So I don't know whether the compiler is smart enough to do that or not. So what we're going to do is rename these to value 0, value 1. This guy gets value 0, value 1, and this becomes value 0. Because register pressure is very important in shaders, and we talked about that why before. So now we're still not actually using those values in this path yet, but we will. So what we want to do is we wanted to try adding some stripes. So we want to, in the building, we want to put recolor base P. It actually wants to be these. And maybe we'd only do it on the front of the building. So instead of Z base, this is now Z Z plus 1. I don't know, and I don't know how we encode this. Let's say all 6 faces, or all the first 4 faces. Color 1, and recolor. Did we break anything? We did not break anything. Wait, how is there a stripe there? I haven't put in any code to do anything with that yet. What? How is that having an effect? Is it? Okay. Weird. But anyway, so our time in the third step of meshing went from 0.28 to 0.28. So it has not slowed down at all by doing just that small number of recolors. So we're touching which update and has update, but we're not touching texture grid. And it's like we're touching texture grid. I don't understand. How does that affect the texture data? Is it just getting set to, is it affecting the interior? It must be affecting the interior. Or we crashed the graphics driver. Oops, that's not what I want to do. Close OBS. Restart OBS. Fix my text stop. Restart OBS. Why does that not fix it? Oh, right. This always has to get done again. All my windows got randomly reshuffled. Why would the graphics driver crash? It didn't crash the first time, and then we reran it without having changed the code, I thought. What did I change? I changed this to I plus equals 3. Yeah, okay, so that was, it ran into random memory doing processing commands. Because I had updated that wrong. Yep, okay. So then, oh, I can't see if it's affecting the interior because it's aligned with it, the thing. Let's put it slightly off. Yeah, I believe that's zeros. I believe somehow the texture has been set to zeros there, but I don't know why the texture will get set to zeros. It's almost as if this if else, somehow this is getting run. Oh, because we're not running that path. Because when I do this, cut and pasted this, I forgot to change that. So it was just generating a slot there. Okay, so now our time update is still 0.28. Okay. So, so now, update 0. if value 0 and 0x100 image store color east address uvec4 of unit color equals value 0 and ff value 0 color. And then let's have this stripe kit added. Yeah, that's oops, yeah. Can't do that. Okay, now our time in the third slot went from 0.28 to 0.28. So now we have to go into the mesher. So we need all this data. We go into mesh from Voxel job. Oh, well, we may not be binding that, so it may not be getting used. Binding 3 and 4 to update and which update. So let's go back to those. Main. Has update and which update. Yeah, which update wasn't getting written, so that might still slow down. Which was, yeah, it's 4. Oh, no, it's still not slow. Okay. So this whole sparse updating thing seems like it's working. Let's say, and now in mesh from Voxel, we have to do this stuff as well. Let's do it in this order. This was some old logic. We weren't binding all of them. Okay, so now they're available to the mesher. Run it and make sure we didn't screw anything up. We want to sanity check so we don't reset the driver. So the sanity check is here. If this gets too big, it blows up. Well, it's this loop. So k is less than what's the most number of voxels we could reasonably do? 256 by 256 by 4. Which we can just do num voxels equals clamp to at most num voxels. Let's do 8 by 26 by 26. I don't think you, if we were ever to do like a thick thing, it could be bigger. Right, because the problem was that we were reading random memory, and so then somehow these links, even though this was getting clamped, somehow these links were blowing up. I guess ZLen must have just blown up to something really big. Although it can only be Z0 plus the bitfield extract. So it really could only be 11 bits big, so I don't know. I'm not sure why that would cause a crash. I mean, usually the crash is just a timeout. It's spending too long in a loop. Anyway. Let's say that. So back in this one, we now want make voxel to take face colors. So we say if has update and mask does not equal 0, then we can read which update that's the has update mask. This is the which update mask. But we actually don't need to do it. We go int uint bits equals which update slot shift right 8 times Z and 3. If bits and 0, 1. R, and this is color is that, then color.r color.x is midfield insert x08. So we pack the changed colors. Into those things. That takes color. Then we're going to make voxel. What? Okay. UVec3 color. Field extract. It's a 2-vec color dot x 08 field extract color dot y. You may be wondering, why are these being packed into bit fields and not just stored as 6 separate values? And the answer to that is register pressure in the GPU. There's a tiny hope that this will pack and unpack them rather than taking up 6 registers. They'll only take 2 registers. We could be bigger than 8-bit color. We have, what, 6 bits of which faces to assign it to. We could actually pack 10-bit color plus the 6 faces is 16 bits. We could actually pack 2 of those into a single draw command. And then because these, if we're packing 3 colors into 32 bits, these can fit 10 bits per color. So we could have a slightly more colors, but 8 bits is fine. You know, I think there's actually a pack and unpack 8-bit values that I should probably be using. It might be in Voxel. Unpack. No, it's not in here. Wonder where I used that. Because there's a thing for unpacking half floats from raw bits, and I feel like there's also a thing for unpacking bytes. Unpack half 2x16 GLSL. So is there an unpack byte? 8x4, 4x8. I feel like there's some shorthand function for this. Like in an ideal world, it would be cross-referenced here. I feel like there's an unpack 4. But maybe it's, the problem is this is indexing by floating point. See if chat knows. unpack. What was it? Unpack 2 by 16? Yeah. Unpack. So it would be unpack 4 by 8. Unpack unorm. Oh, it's for convert. It's still when you're converting to floats. So yeah, there isn't. Unpack unorm 4 by 8. Yeah, so there isn't, if you're just using them as ints, there's no unpack function, and the bit field extract is the right thing to do. I could maybe make one just to clean things up, but anywho, so now make voxel face pair now takes a uint C1, uint C2, and we do not have anywhere to store it. So now our voxel has to be a UVec3. We're using 24 bits here, and this is using, if C is limited to 10 bits, this goes up to 26. So there's 4 bits. There's 4 bits free here, and could be 8 bits free here. There's this TUTV thing we start to add. I think I'm going to get rid of. Make voxel. Oh, it's voxel mesh. It's now UVec3. Voxel fragment. No voxel vertex. This is now UVec3. Data is UV3. So now we have a color. We're not going to use the TUTV anymore, because we're going to do something different for that. 0, 0, 1, 0, 1, 1, 0, 1. And so we need a palette for our colors, but we'll just hack it for now. Color equals, how do we determine which texture we're using? Which face? No, which face? It's just larger. Yeah, larger is used here. This is just larger. 0:12. And in the same way, we have the field extract data.z larger. So then we just say if color equals 1, we'll do a purple, and in color, out color equals that's color times in color. Clear. Okay, that's never going to work, but yeah. Okay, yeah. The mesh from Voxel job. These all aren't write only. Now they're read only. Close to casts. It's probably not this function. It's probably this function. No, we explicitly did this thing here. Where was this being used? It's the Voxel mesh from Voxel job. Yeah, did the same thing here. Mesh from Voxel job, line 1 or 2. Has update should be, that might have been telling us the wrong line. Yeah, these are uints. Undefined variable mask, yeah. HMask, HMask. Okay, they all turned purple. The default value of color is 0. So if we assume none of this runs, let's just force none of it to run. Yeah. So we're passing in color 0. This becomes 0 if this is doing the right thing. Extract 8 bits of color. We pass in 0. So the third value is all zeros. Oh, yeah. These two are backwards. All right. At least we know that code is working. Okay, so nothing is showing as purple. So something isn't getting through. We need to, it's not going to be this, I don't think, but we do need to update this barrier. Because we're reading these values, so we need to do this. GL memory barrier. Shader image access, maybe? Yeah. We need to do that, but I doubt that that's the issue. It's probably just a logic error in all those masks, setting all those masks. So we just have to check that code. So build texture grid. So we go in here, we atomic OR 1 bit. If that value was 0, then we initialize this. There's a race here. If it's 0, we need to be ANDing it. And then, yeah, we never updated. Oh, well, we were doing the wrong thing. Which update of slot of value 0, shift right 8, and 0xff. We can just do a bit, this can be expressed as bit field insert into 0, value 0, shift right 8 to 8 times cn3 int z shift equals cn3. Let's do that. 8 times cn3. So we make sure those bits are clear, because now they're valid to read. We wrote into here that it's valid to read which update. So we 0 those bits. Then when we actually, but we only do that if it was 0. Then there's a race condition here if two things were to write to the same thing at the same time, but that will actually never happen because of the way the parallelism is going at this point. Nobody else can be writing to this voxel. So this is now z shift 8. Okay, so that creates, this extracts those bits, the exact same bits that we're testing here. Those 6 bits are extracted here, then they're shifted into the right spot to then do an atomic OR to update the value. That seems right. But the old code was 138. But the old code was setting those bits incorrectly, with the wrong logic, but was setting those bits and nothing was happening. All right, well, it hasn't gotten any slower, at least, even if it's not working. So it's possible, let's just force value here. Value 0 equals 0x f01. I believe that's the value we're supposedly writing anyway. So these should all get written. Assuming they're being bound. They're UImage 3Ds. Did we change that? We bind them here. Yeah, we don't have to mention what dimensionality they are. We just bind them. Assuming we're creating them. Yeah, they're getting created. Okay, let's... Oh. We disabled that code temporarily. Nope, okay, it doesn't matter. I believe this step has gotten slower. Although, of course, yeah. Okay. Let's just say color.x equals that actually. Okay. So we're getting one stripe on each building, which is weird because we're writing one per floor. Right? It's inside the floor loop. Right here. So we should be getting multiples of them. It's on both of them. You can see it interacts with the CSG. It's at the same height, even though the base height is different. That's a bug. So that's actually just happening at some fixed height, unrelated to... Well, I don't know. Let's do plus 3 minus 3. No, okay, that is happening in the specified region, but it's only happening on the first floor. Okay, it's only the first one is applying for some reason. Why is only the first one applying? Is this logic wrong? No, it's just the same as the other ones. Do we get out of sync after we do that? No, because after we do it, we generate the next floor. So are the floors inside still there, or have we blown up the floors inside? We have messed up the floors inside. Okay, so is the color parsing these? No, the color is not parsing these. So who knows what the heck is happening? I is being recomputed from scratch every time, so we don't need that. Outputs when equals type equal command recolor 3.4. Output slot now actually is not going to get scaled. It is going to be absolute terms here. So here we add len. Maybe? Yep, there we go. Okay, we've got recoloring going on, and the third thing has gotten really slow. It went from 0.28 to 0.53. But we are recoloring everything, and we actually only need to recolor one side. So let's get rid of these forced things, see if that works. No, it does not. So we're still not getting this right. Oh, now they're back. Okay. Oh, because I turned them on. Okay, so this step is not working right. No, it is working right now. Okay. All right. And then where else am I forcing something on? I'm remember that I forced something on somewhere. Build texture grid probably. Okay, yeah. All right. No, we're not forcing that one on. Now we want to make it main. Well, yeah, let's do it in main. Put recolor uint faces uint color. This is color for faces should press 8. So then we say faces, color. So let's say 1, 1 now. Instead of all faces, let's do, let's see. It goes east, west, north, south. So we want south, which is 8. Okay, and now the internal one is not getting recolored, whereas it was before. If we put it back to 0F, then we'll see that the interior one is getting recolored. Yeah. And we make it go all the way to the edge. We'll see that the side is getting recolored as well. But if we set it to only do south, then the side won't get recolored. But performance has taken quite a big hit, bigger than I expected, because we're only writing out we're only writing 2 bytes. Maybe it's the utilization is bad, that we knew what's going to happen. It might make sense to do this in its own shader, that, but we still need the culling. It might make sense to cull on a different scale and do a it in its own shader so the utilization can be good. We did. This is putting extra into it. No, let's see this lower. Yeah, 4 still seems to be the sweet spot. Oh, and culling has gotten even slower. Probably because of that indirection that we added. That's interesting. That's a lot slower. Because if we take out the added commands, then that's just the cost of the. Yeah, that's just the cost of adding that indirection. Of instead of having the commands all be the same size. That's a huge jump. It was like 0.2 before, wasn't it? So if that's going to be that expensive to make that indirect, then maybe we do still need to keep them all the same size, which we can do. So go to main. We just say plus plus p. Make that with the same size. And then the color is the only one that's doing this. So so instead of this being indirect, we can say in I equals slot plus, what was it, 16384? Yeah, P started at 16384. And then now, if I get this wrong, it could easily crash the driver. Okay, I screwed something up. Oh, right. No, it's still supposed to be a computed. It's I equals 16384 plus slot times 4 is how that's supposed to work. But it's still not seeing the recolors now. So these are after they remain variable length after getting written to the cull lists. They're only variable length during the call. What is the performance like of this now, though? No, it's still slow. So wait, is that not how it got slow? Did it just get slow because I added more stuff? No, I don't. I'm confused. I thought Twitch allowed live rewind. Down to 0.12 from 0.17, getting faster. I think it's just the sum of all these. In fact, the frame time is actually... This may not be measuring everything that's going on. I haven't even been looking at the frame time, but... why is the mesh not as fast as it was before? Oh, I just said color. It was not in the cull. It was in the first step. So the cull can be... This is fine. Yeah, cull is fine. It's mesh step 0 that's slow. I need to figure out why that is. So we can put erase back. Okay, so we put this one back to only being 3 long. But we can also put this back to only being 2. And then... And then when we parse it, we only had 1. Okay. This doesn't parse its commands. This does. How large was this? Command recolor is 3. Oh, this was failing to parse it properly. I wonder what this was doing then. I wonder if this was slow because it just wasn't parsing it. And this doesn't loop over jobs at all. I think at that point, this is the last. These two loop over the command list, and this loops over the command lists. This loops over the raw command list. These loop over the culled command lists, I think. Let's hope we don't get a driver reset. Command recolor isn't even defined. I need to put this in a common thing. It's so dumb that there's defined 4 times. That's wrong, and mesh is still slow. So somebody's parsing this incorrectly. Let's go back to main, check how we're doing this. 4, 2, and 3. Then we go to command list color, and we're writing it into the offset. So if we go through, indirect through the command list, then we get the correct start point no matter what. So it doesn't matter how we parse it. Still wrong. All of these loops have these hard-coded limits to prevent the driver to prevent infinite loops or to prevent runaway code if there's a logic error, which causes a driver reset if the code runs for too long due to a runaway bug. Yeah, sorry, I keep letting that get covered up. What did I change? Okay, anyway, so I just checked. They are 4, 2, 3. Color always sees the correct offset, but then it needs to write out 4, 2, and 3. 4, 2, and 3. And we're taking this path, the unreliable ordering. And then occupancy bit array needs to parse that data. 4 and 2. I was misparsing the. Oh, well, that doesn't help. 4 and 2 and 3. And then let's do this correctly. What have I done? Why did it get worse when I fixed this? All right, let's put them all back to 4. they're all 4s. Still nothing. What did I break? When last time I checked, it was generating 2,000 commands to generate those 2 buildings. We always output 4, right? Because we do this, so we output size 4. Yeah, the texture grid doesn't matter because it would still draw something just with the wrong textures. So it's got to be here. Called command spacing, command list I++, command list of I+1. There we go. We've lost our recolor. I think that's because I took it out. Yeah. Okay. So we're back to this state. It's indirected, and the slow thing is mesh steps 0. So we want to look at h mesh of 0. Mesh. H mesh. Oh, mesh time. Okay, which is this compute shader, which is the occupancy shader. So the occupancy shader has gotten slow. Why has the occupancy shader gotten slow? Maybe because the called commands aren't being called correctly? Let's put the sizes back. Another option would be we're making all these copies of the data of the command lists. We're making new command lists for each 8x8 subregion. So we're making 32x32 command lists. We could make those command lists also be indirect. And then when they are reading the command list data from memory, they'll be shared. It'll take less memory, and there'll be more cache sharing. So we probably should do that. But let's first just do this. So we make the links back to multiples of 4, or not multiples of 4, to being variable sized. I by 4, I by 3, I by 2. And then occupancy bit array. Okay. So occupancy bit array is slow. We don't know why. Probably since this recolor doesn't affect this. So there's no reason that our adding this code for recolor should have slowed it down. And it's not indirected because the indirection is only on the culling step. So I don't know why this has gotten slow. Unless I'm misremembering how fast it was. I can't easily get back to the previous version. Because I haven't changed this at all, I don't think. Yeah, how many commands do I have in that sense? There's still only 3 bits reserved, and as you can see from the pound defines, there's only I've only implemented 3 because I added recolor. Um, the next thing to do is retexture. Um, but I'd like to know why this has gotten slow. But unless I can check out an old version and figure out what's changed, it's probably pretty hopeless to try to just do it by guessing. Because it's this file that's gotten slow. Yeah, that doesn't make any difference. Anyway, so I mentioned before that this is going to be Voxel week, and the idea is that since this is what was fast enough, I'm just going to add these couple minor features, the retexturing and the recoloring, and then during the week we can work on actually generating a city. That was the idea. And then maybe Friday will actually be non-voxel. Maybe Friday I would actually work on the STB libraries. Because that's been a pending task for a while now. I mean, so text compare. C colon showing purge ZMC2 purge games ZMC2 of occupancy shaders occupancy bit array VRAM, and then equal occupancy bit array VRAM. Okay, so this is before I added recolor. So I just changed how I compute the I. Yeah, that's the only thing that's changed. I don't know. I don't know why this has gotten slow. Maybe I'm just misremembering. No, because I added them all up and it was only 0.5 milliseconds. Oh, and maybe that's OBS. I'm going to stop just so I can check the timing. I'm going to turn off OBS. So you'll lose the screen for a second. But no, it's still slow. It's not OBS. Why does the... Oh, there it goes. Okay. I don't know. Don't know why that's gotten slow. Maybe it would fix itself on a reboot, right? Like, who knows? I can't easily revert because CMirror doesn't actually have a clean revert. I have to kind of manually do it, and I will do that off stream later if... But yeah, so either reverting back will fix it, and then I can diff it and figure out what's changed, or rebooting fixes it, or neither, and it's a mystery failure. So I think we just won't worry about it for now. We'll just keep going. So we've got the recolor working, and the cost of it in ignoring the slower first step. Did I move something else into that block? That might be also. Each mesh time of 0. Perf begin. No. That won't make any difference, but just... the other thing I changed, which should have only made things better, is I changed this. But debug context 2 is supposed to be synchronous and worse. But for some reason that was enabled. You can turn off all the debug contexts. Shouldn't matter. Yeah. But anyway, so we still have the third one has gone from 0.28 to 0.44. So if we focus just on that, we go back to main. Where do we do create a building? Here's where we create a building. Let's only create that on the bottom. Actually, let's do it at I equals 1. Okay, let's not do it at all. Yeah, that's gone up from 0.28 to 0.40. Why do we have so many quads? Oh, just because I made things huge at some point. Just because I made that second building gigantic. Wait, why are these? That's interesting. Some kind of race, probably. Some timing isn't right. Or it could be that we're losing the commands. The commands aren't being called correctly. Weird. I think that it only happens at the bottom. I made those floors really tall. What in a real building spacing between floors. No, high rise, not spacing. High rise building floor height. Typical floor-to-floor heights range from 3 to 4.5 meters, 10 to 15 feet. So we had done 12. So if we want the most, we do 10, and we do like 195 stories. Oh, but then these heights aren't good. What are these? Okay. Yeah. Now, this is so silly from a game design perspective. If we did the zombie thing where there's no power in the city, so there won't be any elevators, you would have to manually go up 100 flights of stairs. You could do that in a reasonable amount of time because you wouldn't have to, like, you would just walk and you would walk up the stairs. So, you know, you would just walk in a sort of spirally thing, but you'd have to turn. Maybe you'd make it go no landings, like landings only on the floor, so you'd go up one floor and then turn 180, go up to the next floor, turn 180. So you would have to turn 50 times. 50, you'd turn 360 50 times, go up that tall. So there's just like, that would be so much stuff in it. Yeah, I've used later versions like for work and find them less. I I uh, I dislike the experience more. Um, make those windows wider. And obviously, like, the thing to do is to make the buildings not just be square shaped, like they can narrow taper as they go up, and just do that by basically stacking smaller and smaller buildings on top of each other in some sense. Um, you know, you do 20 floors at some scale, and then the next 20 floors at a slightly smaller scale. Uh, and they're effectively would be different buildings, just as effectively kind of different buildings as a way to keep the code internally clean, because then the, like, how do you lay out the interior space needs to change as you go up floors, and rather than trying to be like kind of consistent, but oh, it's shrunk a little bit, we're kind of consistent from floor to floor. It's just simpler if it's like, well, now at this size we lay out the floor this way, and the only thing you have to do is make sure you keep that central elevator staircase column. um, so how many quads is that? 1.6 million quads. And obviously you can see that, like, I haven't put the time into like making the windows spaced correctly. Like, right, we just got this basic thing going. I got to figure out what's going on down here at the bottom, why we're losing the windows at the bottom. Wait. Okay, so so that time has now gone up to 0.68. Oh yeah, now how many commands do I have? 3,500. So oh yeah, so that first time is now 1.4 milliseconds. But the third one has gone up to 0.68 because we have so many more things. So then the question was just, if we add the recoloring, does that actually add significant time? And the answer is no. Okay. But it does, if we do a whole bunch of them, it does add significant time. It's now up to 0.73. But if we just do it a little bit here and there, no wait, 0.68 up to 0.73. Oh, that's not that big. So yeah, on this hardware, I think you would just be better off entirely doing this on the CPU, because the CPU is going to be doing almost nothing. Even on this ancient development machine that I use has 4 cores. So you have 1 core doing the game, 1 core doing like physics for the game maybe. So you like maybe use 2 threads for the game itself. And then you can have 1 thread generating the high level description of the thing, and 1 thread dedicated to just doing the meshing. And that would probably be more efficient because you wouldn't be wasting the GPU's time, because the GPU should be spending its time drawing, not spending its time doing that. And you can see our frame rate's gone way down, but we can turn off the meshing so it's not generating the meshing every frame, and now it's 2 milliseconds. Now, of course, that's 1.5 million quads for only 1 chunk, and we want to generate a whole bunch of chunks around us. So if our limit is, say, 20 million quads, we can only be looking at, you know, there's say 2 million quads per chunk. That would only be 10 chunks. So this may just be like, oh, we can't make buildings this big because that's just too many quads. Like, because you have to imagine if this actually was populated with interior walls and furniture and stuff. So that was what I was starting to say, is like, that's just the crazy thing from the game design perspective. It's making a giant building like this. Like, if you know what floor you need to go to, you can sit there and it would still take an annoying amount of time climbing the stairs. But imagine if you're like searching for loot in this building. Like, it's just so big. Like, what in the world are you doing? What is 2108421? That is, if you read it as a string of 5-bit values, right? Like, as written, that's a hex number. But if you wrote it in base 32, it would be 11111111, and that's how the textures are encoded right now. The textures are encoded 5 bits per face. There's 6 faces, 5 bits per face. It's 30 bits, and so it's 1 plus 1 shift left 5 plus 1 shift left 10 plus 1 shift left 15 plus 1 shift left 20, etc. Okay, but anyway, we gotta figure out why we're losing some of our windows on the ground floor. Is it a race condition? Well, it's not a race condition because it's the same every time. Because we're actively... I mean, I guess it could be a race condition, but it is always consistent. But it changes depending on how many recolors I put in. So it's like the recolors are affecting it. Did that happen when I changed from fixed length to variable length? I think it did. Oh no, I'm still on variable. I'm still on fixed length. Didn't I change it to variable length? Oh, this one. This is outputting variable length. So that it doesn't matter that the input is fixed length, because the input uses these pointers, so the input can be fixed length or variable length, and it just does the right thing. You find yourself having to refresh your knowledge of mathematics from time to time? No. Anyway, so the next thing, I have to figure out why this is happening. And then the next thing is to allow texturing, where instead of painting a red stripe, well, first I gotta fix this coloring thing to not be hard-coded. Let's just do that. We want a palette. So the voxel vertex reads a color from Z. Z is 32 bits. It stores 2 colors. It's currently storing 2 8-bit colors. Let's store 2 16-bit colors. And we can store the colors as 15555. So we say incolor.r equals bit field extract color 0 5 over 31.0. I don't know what we'll use the other bit for. 10, 15. Might be better to do this extraction in the fragment shader. Yeah, whatever. And then in the mesh from Voxel job, make Voxel face pair is going to be C1, C2 shift left 16. But then we're going to say color palette. And anybody want to hunt around on the internet and find a fun 256 color palette? We could use like some, we just want a big broad distribution of colors, but you know, we could use you know, some retro console just as a starting point. So something like if there's a console that had a 256 color palette, like the Atari 8-bit had a 128 color palette. A palette meaning not meaning the palette, like they often had like a 4-color palette, but the colors were chosen from 256 unique colors. Yes, 256. Palette. Shader storage 6 times 4. Update buffer palette SSBO 0 26 times 4 palette units 32 palette 56 equals to use the whatever the default VGA palette is. Could just index R, G, and B into it like this. Six by 8x5. Three, 2. Did they not have the Atari 8-bit in here? I wonder why. I guess because you couldn't really display an arbitrary image with it, but... Oh, video game consoles. Okay, no. Yep, 4 out of 128. That's their attempt at this. Sega Master System 64. This is out of 512. 512 being 3-bit, 3-bit, 3-bit. Yeah, I don't want 256 out of n. I want n out of 256. We could just do it 332. Okay, yeah, here's a better version of that 128 color palette. Oh, so the GTIA actually has 256. So, for example, here's an example of a 256 color palette. But it doesn't provide it as numbers. It only provides it as a color chart, and I want the actual numbers. GTIA palette RGB values. It's an executable. That's not helpful. Not going to link to it. Just going to say I found it. Why is that 7 wide? Okay, so here's a palette, 256 entries. We want to convert it to 555. So let's find where we use it. No, they're listed in the opposite order, right? They're listed visually R, then G, then B. So R is the high bits. And then we're going to shift these all down to only 5 bits. And then we reassemble it. I guess I should do it in the same reverse order. And then when we make and then when we use it in the vertex shader, we decode R is at 15. Or 10. That was all wrong anyway. 5, 0. All right. And then the default, which one is white in main? This one, which is color 15. I'm going to just reverse this. FEDCBA9876543. Okay, so now color 0 is white. And it is not using the palette correctly because his string 0 is black. Okay, these are coming in as 0. Yep, okay. Color is coming in as 0. That's coming from this. Oh, I probably didn't bind palette. Palette is in 5. Oops, oh, I already replicated that. Okay, and that's just this slightly darker stripe because we used color 1. So now we go back to that palette. the top row is reversed, and we want this bright purple, which is, I believe that means it's 0x65. So we go to main, we go to build, compute building, something building, crate building, and we want the color, the face is 8, and the color is 0x65. And that's that dark purple. And it's dark just because it's multiplied by the asphalt color. So we want to go to like 6A maybe. Okay. So now it's about where it was before. And we still have to figure out these holes at the bottom. Okay. And then we do the texturing once we figure out why we're losing windows. Could it be that we just don't have enough buffer storage? We're 4,000 entries. Each one uses about 3. So it's about 12,000. No, but then once we call them, it's a lot smaller. So what would do that? Okay, let's check that if we draw more of them, that it changes which windows go missing. Maybe it didn't. No, that one did. So the number of them does change it seems like. Yeah. That changed which windows are failing. So, wait, how is that? What is the hardest part of making graphic drivers, etc.? What do you mean by graphic drivers? That's a jargon term that I'm doubtful it's the jargon meaning is what you mean. So I'm not sure what you mean by it. What? What? I guess that thing I was talking about, the number of quads being bad, that's on this old hardware, right? That on the 660 Ti, I was drawing 40 million triangles at 30 frames per second. So on the 980 Ti, you know, 40 million quads is probably reasonable, but on a higher end machine, it can draw more. So that's probably okay. The person may not even be here anymore. I forget how you get the list of people. Probably can't from the pop out. Oh, yeah. No, he is still here. Go. Graphic drivers. What do you mean by graphic drivers? What would make these windows disappear? We must be parsing something wrong. But it's hiding windows that we drew earlier. Well, no, because this is also affecting the second building. If floor height equals 10, so let's remove them from the first building. Okay, so we get that pattern, and then change it to only that one. That maybe look the same. Yeah, okay. So it probably is a parse problem because it's probably being affected by the stuff before it. 4, 2, 3. Four, 3, 2. That's correct because it switched which one we're looking at. There's nothing else incrementing I. And then on output, recolors 3, erases 2, slab is 4. It all looks correct. Yes, this is a hobby project. Or I'm a self-employed game developer and it's a game project? I mean, I don't know. Hard to say. I don't really have any plans to ship a game with it. I mean, I may ship a game with it, but we're just trying to make it work. What could be going wrong here? Especially given this was working before. All right, if we never put any recolors in. We tried this before. I don't remember what the result was. We never put any recolors in. It's still broken. Oh. Okay, if we don't put in the floors, and what do we get? Still the same thing. But only on the 0th floor. It's so weird that it's only the bottom floor. That's what makes it feel more like a race condition. Like these are going wrong, but only when I is 0. Okay. If I is 0, continue. So we'll see if then it happens on the 2nd floor. Yes, it does. So the first floor that gets built in the 2nd building. What a weird failure mode. Like we're successfully parsing so much stuff. Memory getting overwritten because we don't have enough. Because we did make the building taller, so that generated more commands. So nope, still happening. Yeah. Look at that. Happening so consistently. Oh, it is happening on this one too. Might have been doing the whole time and I just didn't notice it. Yeah. We're just randomly losing some of them. It's so strange. What? How would that happen? So the occupancy is wrong. Can we, is it possible to iterate over the main command list instead of the original command list? Go to main. Do the occupancy shader. Two is getting used for something else. These are old and not being used. Shouldn't this only be using the split job buffer? Yeah, probably. Where's jump storage? Yeah. So now we can get at raw command list. That variable isn't used anymore. I hate that they do that. When they optimize that, the variable, you can't set the uniform anymore, so you can't tell the difference between a buggy uniform call and an optimized out. and now it's very slow because it's parsing the full command list. And if it parses the full command list, there's no dropouts. Okay. So the culled command lists are bad. Maybe they're not large enough. Although we've shrunk the building a lot, so it shouldn't be using too many commands. That should be culled command spacing. I mean, it was hard-coded at A192, which is fine. So that won't change anything. Yeah, and it's small enough. This is small enough that there's no way we're overflowing that. So how is it losing some of these? Commands? Is it not detecting the region correctly? That's this. Is in I plus 1, I plus 1. We run height of 2, so we do both coarse and normal. The coarse spacing is 1024. Pos x and pos y are 0 to 31. So this adds up to 1024, so coarse 0 to 1024. What? It's so close to working. It was working. Oh, this is so annoying. I think it was working. And maybe it's time for me to do something with CMirror to make it possible to revert more easily. What could go wrong? How could this go wrong? We're just losing some windows, so it's like the window commands aren't being parsed correctly or they're being called. The entire window disappears, and they're not lined up with the 8x8s. The window spacing is 10 and 12. Let's make the window spacing 16 so that they're consistently lining up with the 8x8s. No, it's still a random dropout pattern. So they're following a consistent pattern relative to the 8x8s. Is it this atomic add? Am I missing something about this? Because I did change how all this works. What happened when I fed it back to they were all equal sized? Len equals 4. Did I do that? I don't remember if I did it. I think I did it and it was still the same. Pretty sure I did that. Yeah, I remember the code being that way. But we'll do it again. That fixes it. Fixed length commands, it works. But the recolor doesn't work. Fixed length commands works, but no recolor. Oh, no, because I've disabled recolor. Okay. All right, fixed length commands works. So there's some bug with the non-fixed length commands. So we output, if it's recolor, we output 3. If it's erase, we output 2. If it's slab, we output 4. And that happens in this atomic add. Build texture grid 4, 3, 2. Makes perfect sense. Occupancy, which is the one that has to be going wrong. Recolor is 3, slab is 4, erase is 2. I plus 1, I plus equals 4 or 2. We don't use I again. We use a different I here. It seems totally legit. But that breaks. Somehow that breaks. Okay, let's look one more time at what we're outputting. We add len. Len is... I do not drink alcohol currently. I guess my go-to drink back when I was drinking with any frequency was a White Russian. Kahlua, vodka, milk. So the erase comes in here like that. Len was 2. We offset by 2. Maybe the unreliable ordering. Maybe it's the unreliable ordering. You know, if unreliable ordering value equals 1. maybe that, because the atomic append offset pre, it shouldn't matter. It shouldn't be using that at all. But yeah, it does matter. Why would this being variable length? I mean, I guess I'll just put it back to fixed width and worry about it another day. Super annoying though. Band erase I plus equals 2. Slab and recolor plus equals 4 plus equals 3. If we don't put any recolors in, it still happens. So it's not a problem with recolor specifically. Somehow erases. The fact that it happens so infrequently really feels like an ordering problem. But I'm not sure why that would change. I'm not sure that would depend on why it would depend on length being varying. But maybe if they're different lengths, maybe it really is unreliable ordering. It could be. It could just be that the unreliable ordering doesn't support variable lengths. So we'll do that for now. I mean, it used to support it. That's why I'm confused. I'm pretty sure. Maybe not. Maybe I only ever had that working with fixed length. The recolor is gone because I disabled it, I think. Yeah. And we can make this tall again. No, I have nothing to do with nothing phones. That's totally unrelated concept. Okay, and then we messed with the width of the windows. So these were 12 and 10, I think, or maybe vice versa. Why is the... Oh, because I removed it. Let's see, the roof is not there. Okay. All right, well, we'll not worry about that. We'll just use our fixed length things. So now we want to add a retexture command. and it can use the exact same code. And then occupancy bit array ignores it. Occupancy array ignores it. Build texture grid is going to do something with it. We're going to do this update up to there. It's all the same. And then we say if type equals command recolor. Then we do the recoloring. Else type equals command retexture. Quick break. Be back in a minute. So this issue stems from atomic add. Maybe. I'm not 100% sure that that's what's going wrong. But the thing is that the way this works is on a GPU is that you have these SIMD lanes. You have 32 SIMD lanes, and they're all calling the atomic add at the same time. And so the question becomes, what order do the atomic adds happen in? And the unreliable ordering means I'm not guaranteed that code path when unreliable ordering is enabled, which it is, doesn't guarantee. It means we don't know that the lanes are going to go in order. That the first lane gets the first atomic add, the second lane gets the next atomic add, the third lane gets the next atomic add. There's no guarantee of that from the API. If it happens to do it, then the whole system will work correctly. So the behavior that we're getting is consistent with the atomic add does have that behavior if they all use the exact same value, and has inconsistent behavior if they have different values. I'm not saying that's definitely what's happening, but that's a consistent thing. And it does make sense that the hardware might be optimized to handle that case differently. That if they all are using the same value, there's a special path that does it in a special, efficient way. I have a bunch of code that tries to do it myself in a special, efficient way, but it wasn't working. And so we had to turn on that unreliable code path that we know is unreliable. So probably what's happening is that unreliable code path is triggering and causing that behavior. Not positive, but probably. The whole thing is that because we're not given any guarantees about how that atomic add works, naively, when we have 32 SIMD lanes and we do 32 atomic adds, naively, the hardware could reach out to that memory 32 times and request atomic adds, and each one requires a full round trip, and that would be slow. Because atomic adds are all adds, you can reduce that to a single atomic add. You add up what are the 32 lanes all going to add. Look, some of them are adding 0 because they're disabled, and some of them are adding 1, 2, 3, or 4. So you add up what all of them are adding, and you do a single atomic add, and then you reconstruct what each one would have computed if they were done independently. And that's what the extra code that I have written that doesn't work right does. And I have used it elsewhere and it did work right. So I'm not sure why it wasn't working right here. And probably the hardware is doing something like that behind the scenes itself without me having to write code to do it. But if the hardware does it, there's no guarantee that the hardware puts them in the right order in reconstructing what the values they would have gotten were. It might be like sorting them. Maybe it's doing all the ones that add 1. Like it could actually be, the hardware could work like this. All the lanes that add 1 run in parallel and get the correct order. All the lanes that add 2 run in parallel and get the correct order. And all the lanes that add 3 run in parallel and get the correct order. And if they did that, because they're different lengths, they would run out of order. They wouldn't run in strict order. So it could be something like that is happening. except that I thought the code was working with the variable lengths before, but maybe it wasn't. Maybe that was going wrong, or maybe I didn't notice it. So this needs to be type command texture. So, so the retexture is going to say we're going to store a 16-bit value into one of the two retextures. Retext 0, retext 1. So we'll use if value 0 and 1000, then we atomic, oh, we don't atomic, or we image store tech 1 B plus image store retech 0 retech 4 B, we atomic or oh yeah, there's this. No, this is value 0, and that's just value Z shift date. Call that mask. Unit mask equals 0x 10 20 mask equals 0 10. So we store to one of the slots, and we store which slot we updated. That's build texture grid. Did we do this here already? It just happens automatically. Occupancy bit array just needs to ignore it. We did that. And then main, we need to build it. Put retexture. So we could pack two retextures in this, actually. Let's actually make it work that way. So then build texture grid, we actually do something different. We say mask equals 0 if the bottom bits are non-zero. Then we set that one. if the top bits not 0, if v is not 0, let's do it like this. Let's do it like this. Bit field extract v 0 16 v 16 16. So in the bottom 16 bits we store the value we want to retexture with, and in the top 16 bits we store the value we want to retexture with. Now you might think, well, what if you want to retexture with 0? But that's not what those 16-bit values are. They're not actually textures. They are textures plus some face bits. And one of the face bits needs to be non-zero. So, in fact, these will always be non-zero if they're doing anything. So now we go to mesh from Voxel job. And we say uint retec equals 0. Bits and it's 40, so I didn't set those correctly. That should be 40 to 80. Load retec 0. Retec 1. Retec 0, retec 1, 16 bits. Now this is where it gets complicated. Okay, we don't want to take up too much texture space here, so this is the 32-bit texture. First we unpack the 32-bit texture to a UVec2. Unpack texture. So we'll just call it utext for unpack texture. So the unpack texture get field insert utec vex at 0 10 bits, and the value is bit field extract text 05 like that. These are all X. Again, we want to save registers. That's why we're not unpacking this to 6 separate values. So now we take 15, 20, 5. So now we have 6 separate textures. So we took 6 separate textures that each took up only 5 bits. And we've expanded it so they now take up 10 bits. And that lets us assign them here. Replace textures utech, C. We'll make it we could make it in out, but just to be explicit, we'll do it like this. And then here, instead of this UVec3 stuff that's making it explicit, we'll just pass in utech. And so now make voxel can't use text neg x, text neg y, because this is now UVec2 text. And this is bit field extract. Text.x 0,10 bit field extract text.y 0,10. So we extract those bits. This is such a long line, it's terrible, but it makes the parallel between them explicit, which makes it easier to spot bugs. But maybe I should find a different way to do this. So I think that's correct. What step have I left out? Where have I forgotten to do stuff? I'm obviously not actually generating any, but just try running it and see what happens. Replace textures. We didn't write replace textures. UVec2, replace textures. UVec2, text, uint c. Uint face flags equals faces equals c shift right 8. Faces is bit field. That wasn't the right math anyway, but bit field extract c 10, 6. Uint replacement texture is bit field extract c, 0,10. Which texture to do, which faces to apply to. So then, if faces and 1, so we can do that in place. That can be C and 0x. The last one will be 8,000. There's going to be 6 of them. So this goes 4, 2, 1, 0, 8, 0, 4. Artec dot x equals bit field insert artec dot x. No, not artec, text. Text.x equals text.x. We insert our text at 0, 10 bits. Okay. everything is still working. So now we need to actually generate it. So we will go back to main, put retexture, faces, all faces, and which texture to use, texture 6, texture 5, I guess. Put retexture. Oh, right, it's like that. So uint pack retec, uint faces, uint texture, return faces shift left 10, or tech. So this is now pack retec. Retec uint faces. Int star is in the wrong place, so we have the wrong number of these. XYZ, retec. Oh, that was a cut and paste bug. Alright, is that a different texture? No, it's a different color. It's accidentally turning that into color. Oh, because I forgot to do that. All right. Let's hope we don't crash. Nothing happened. All right. So we have bug, or we're already using 5. Let's look at what the list of textures are. Where do we load the textures? Here we go. Floor is regular. 0, 1, 2, 3, 4. Let's use 4. Let's see what that looks like first. Okay, that's what we're looking for. If we set it to 4. So we want to set it to 4. And we see nothing. All right. So we're packing retexture. So our faces are set to all faces. That's actually 3F, it's all faces. Then in command list color, we don't care about type at all. We just always do this. Yeah, we make sure we copy out the third value. Then occupancy bit array should ignore it, and it does. And then build texture grid is where the complexity is. So if the type is retexture, set mask to 0. If you're extracting from an uninitialized variable and it didn't complain, that should be value 0. I think. Yeah. Still not there. So we extract out those bits and we store them into retext 0 and we set the 40. Then we set that into which update and we've already updated has update. So then in mesh from voxel job, we see has update is marked. So then we check for 40 and 80. We call replace textures. Just force that. Oh, we have to assign it. We also have to spell it correctly. So that should have changed that one as well. All right, let's just always change it. Whoops. Too many times. Let's just always apply this. See if the bug is that replace textures isn't working. Yeah, replace textures is not working. All right, let's look at replace textures. There we go. It's not applying quite to everything, as these top and bottom faces aren't changing. The top and bottom faces are these two. Oh, because I'm doing 3F. That should be F3. Okay, but now these sides aren't right. We're not getting east and west. Oh, it should be FC. So it's the high 6 bits are FC. Yeah, okay. So now we're doing that. So now we go back into main and we do pack 3F, comma 4, and that the 3F gets shifted by 10, which should make it 0xFC. Auto did not show me the return value. I want that in hex. Oh, come on. 64516. Oops, I just typed it. FC04. Yeah, okay. That's exactly what it should be. Oh, there it is. Okay. That worked. We retextured. Is that because did we leave any extra floating stuff? I don't think so. Okay, so we have retexturing working and we have recoloring working. Yes, somebody just somebody a while back pointed out my bug that I already fixed. So let's do this. So now we get each texture, the first 8 textures, and one of them gets recolored. The recolor one didn't change. Well, maybe that is texture 1. Probably it is, in fact. And we can, like, you know, make it cover a larger area. Notice this time has grown a bunch. So it's at 0.94 if we put this back to 1. Oh, it's still 0.93. That might just be because this thing is so tall now. Anyway, yeah, so look, everything is just getting slower and slower. Our frame rate's still fine if we're not remeshing, but as soon as we remesh every frame, we're spending a lot of time remeshing now. Occupancy has gotten slower again. I think it's just because the occupancy is still having to traverse all of those recolor commands. And lots of them do nothing, but then they should just skip them. They should all be executing in lockstep. So if there's occupancy, if the occupancy thing is hitting recolors and retextures, it should just skip them. Okay, let's take out all of the recolors and look at the occupancy timing again. Oh no, it's just slow. It's just gotten slow. It's slower again. Maybe it's because I bumped the height up again. I don't remember. It's just the number of commands that we're processing. So many windows to process. In fact, that's an interesting observation here, is it would actually be faster, instead of drawing all those windows separately, it would actually be faster to draw these as columns and horizontal beams, instead of drawing one big slab and then 95 by however many 10 things. Like the number of vertical slabs, vertical stripes is, call it 11. So let's pretend that's 10 windows wide. So the number of vertical slabs is 11, and the number of horizontal slabs is 95 for the floors. And if you just drew them that way, built them that way, it would be 95 plus 11 commands. But the windows are 95 times 10 commands. So you could actually draw this a lot more efficiently if you didn't draw the windows separately, in terms of the number of commands, at least. It's just sort of convenient to get to draw the windows as wholes, because it lets you put the space. They don't have to be spaced the same, on every, right? We could alternate them on alternate lines. Right, like we could say, that needs to be like that. Right, now they're staggered, and so you couldn't just draw that with those single beams. But realistically, the other pattern is probably more common in the real world, so maybe it's worth actually constructing the exterior wall that way. But that's a 4-hour stream. We got that the recoloring and retexturing working. So I think that's a good stopping point. So any questions? You can ask questions about what we just worked on, ask questions about this project, ask questions about anything at all, not even to do with the stream. Recolor and retexture. So these are sparse. Recolor and retexture, because they're only efficient if you only do it a little. Recolor and retexture. Voxel generation. check it in. What IDE are you using? Right here. Yeah, that's the problem is like I am trying to make sure I basically stream it all. I did some work off stream, but yeah, it doesn't make sense. Like you can't check it out and look at it, and so the only way to keep up is to watch all the streams. And even playing it at 1.25, it's just a lot of hours. I could do a I could do a stream where I just like go through what's going on, overview. There was an overview stream. Where I did a bunch of whiteboard stuff talking about how the Bitfield stuff works. Let me check which one that was. But you might have seen it. This was a while back. Depends on how long you've been gone. It wasn't an overview. It was talking about like what's going on with the Bitfield stuff, etc. It was explaining what's actually going on with visual aids. Maybe this one. Yeah, I think it's this one. So that's 11 days ago. So it depends whether you were around for that. So yeah, that's a good thing where I try to walk through what's going on with this Voxel GPU compute shader mesh generation thing, with the how it's working technically. But it doesn't cover obviously the stuff I just did today, since it's a week old. Any other questions? It's really weird that Temple OS has become the touchstone for people. Maybe it's not weird. It's weird that people use the crazy guy as their touchstone for basic traditional programming. Like why is basic traditional programming now viewed as the weirdo crazy guy programming? I'm assuming it's because of a deep misunderstanding. I mean, obviously I am idiosyncratic a little bit, but like, do people go into Casey's stream and talk about Temple OS? I'm not offended. I'm curious why. Like, maybe there's something I could take offense at, but I assume there's like I've never seen the guy, but maybe he's was old and gray-haired, white-haired. I don't know. So like maybe they're just making some analogy to that rather than the programming style. I don't know. Maybe it's just because I'm using old IDE. Yeah, it's just that like that's not the first time I've seen the Temple OS comparison in chat. It's like the third time, and so I'm just curious why that's how have people been educated stupid so that that's how what they think when they see this. What's the source of that? I mean, it doesn't matter. I'm just kind of it's just kind of curious. You plan to do those IK solvers for skin meshes in this project like you had in the old project? Yeah, it's not even for skin meshes. It's just an IK solver for the bones, underlying bones. Um, it's higher chance to see Temple OS on video than Win95 style interface. Um, is it? How many people use Temple OS? I thought nobody uses Temple OS. People are not intrinsically interested in programming first perceived low level programming. I guess maybe, yeah, because since Temple OS is obviously low level. Um, I mean, GPU compute isn't really low level in one sense, but yeah, I know what you mean. Like, it's systems programming still, basically. Um, and of course, this is not Win 95; it is Windows 7. But yes, it is themed like Windows 95. Um, oh, anyway, so the IK solvers. I don't know. I don't know what this project is going to be. If it does get populated with characters, I will almost certainly use that IK solver thing. Um, the important thing is what's the not Wolfram? What's the wolf? What's the indie game with the jumping rabbit? David somebody. I'm pretty sure I followed him on Twitter. I'm not sure if I follow my Wolf. What? Nobody knows what the jumping rabbit is. Wolf. Wolf. Wolfire. That's the name I was trying to think of. So Wolfire has a couple of really good videos about indie animation, indie game character animation. Yeah, it's Overgrowth, but Wolfire was what I was trying to think of. Um, it says public. Yeah, so I'll copy this in. Oh, somebody already put it in. um, and so it's this really amazing, great video about. They don't even necessarily do this method anymore, but the idea is basically you just generate a very minimal number of keyframes. But the fundamental thing you do is that you make a ball or capsule or something. There's another video. This is the one I meant, but there's an earlier video that like gets at even more of the core idea, um, which is that you like just make a sphere or a capsule and use that for your physics. That's what moves around the world and that you do your gameplay thing on. And then the animation is entirely presentational. You make the character animate and follow the sphere. And, you know, you give the sphere's physics its facing a particular direction, and you give it momentum and physics that makes the animation look good. So, you sidestepping should be slower. If you're moving sideways of your facing, that's slower, and backwards is slower, whatever. But then you just do, you add I should find this. I should find that earlier talk too, because I don't know if he. I feel like maybe like you want something that's a combination of both of them. Like maybe you really have to watch both. Like maybe this one is good. Maybe the second one totally supplants the first one, and you don't need the first one. Um, but yeah, here's the earlier one. So he shows that you have the sphere, and you just make the sphere move around. And here he's showing it's tilting, and then he's adding feet, and then he makes the feet run. And you could see that this is like what my thing looked like. I had these stacked spheres. I was going through this process. And so now he makes the feet run, and he connects them with a really simple IK. And you can see like it stretches out really weird if necessary to match. And so you go through this process. That gives you the set of bones. And then you can match those to your character model and use those as the bones in your character model. But underlying the whole thing the whole time is the fact that this physics is really just that sphere moving around. And so that two-step process of you think of it, you let the animation. So like the thing is, when you do this correctly, in the end, it doesn't matter that what your physics actually is a sphere. You've successfully constrained the sphere enough, and then the animation tracks the sphere and predicts the sphere even potentially a little bit to make the motion. Well, and so then you go to the second video then after that, the one I just showed, to get the sort of high quality version where he does use some keyframes and animates between them and stuff. But you still have that same kind of logic that you're animating to follow the underlying sphere. I think it's been a long time since I watched it. But anyway, so yeah, that is what we were seeing in the other one was the beginnings of that same idea. And so I think if I were to put characters into this, they would almost certainly be blocky characters rather than skinned characters. If I go to Voxel, why does this? Oh, because platform changed. These characters don't have poses really, but I would probably do characters like these. I might just do low poly non-voxel characters, but I might do characters like these so they have a voxel look to match the rest of the game. And so then you can't really see it here, but let's find one who's not buried in the terrain. I have an idea. So if you've seen in Minecraft how the limbs interpenetrate, so a thing you could do is you could skin it, but make like the connection like at the shoulder here. The connection could be a square, like so the shoulder, the first green shoulder voxel and the first gray shoulder voxel. The green voxel is constrained. One face is constrained to stay connected to the gray exactly, and then everything else pivots. You could do that, but what I'm thinking I would do actually is basically treat the body as a collection of stretched cubes, right? Rectangular parallel bipeds, and pivot like that corner of the green thing, that corner, the entire arm might pivot around that corner, and so it would never interpenetrate. It would tilt around that corner, and then the elbow would pivot around like that point that's at the center, uh, the elbow would pivot there or something like that. And so you might get this look of voxel characters that don't interpenetrate themselves at all, but dangle. They dangle just only attached at a corner, just as a like a different look. So that's an idea that I had for this, and I could bring that over to this as well. But then they still need bone directions and stuff, and so you can still use the exact same logic to do it. You just don't. You just pivot from kind of weird places to give them a different look, and you actually change the pivot point. Like if it if the arm goes back behind, then pivoting at that point would interpenetrate. So you switch the pivot point from the front of the shoulder to the back of the shoulder when the arm goes backwards. And so what happens is as it pivots, there's these two potential pivot points, and this one is the pivot point, and the the other point rotates back and connects. Now both of them are touching, and now you pivot around the other one, and it rotates like that. And that means the pivot point is changing, so you have to either change the IK depending, or it just kind of fakes how the bones match to the IK a little bit. Anyway, that's an idea. I don't know. I don't know what game this would be. I I have no idea. Um, you know, Infinite City. Who knows? It's really as almost always, it's a solution in search of a problem. The solution, the problem here, the thing that we're solving is how do you make an infinite city that you have random access to? The but what game design requires that? So yeah, like the old version of this, the game design was sort of it predates Helldivers 2, but kind of Helldivers 2 esque. But the idea is that in Helldivers 2 you drop down to a random mission, and those maps are semi-random or something. I'm not sure. Are there just a large number of fixed maps, or are they constructed from modular components or something? I'm not quite sure how they work that. But you could imagine that one thing that you do is you get these missions and you drop down to the mission and it just picks a random place in this giant city, and it will be consistent with itself if the like if you've got two missions and they happen to be near to each other, you could actually find the locations from the other one, whether there'd be any persistent dead bodies from it or whatever. I don't know. um, there's a certain amount of stuff you could do intentionally with that, where you start by doing a mission at a location, and that uh, um, makes that area more available, and so then you get, once somebody has won that mission, then some adjacent areas that are reachable. Like you could imagine that um, maybe the way you get down to this infinite city is you're in space in these space station, and you teleport. Like there's teleporters on the ground, but most of the teleporters are disabled because power's out. Um, so there are certain ways down to maybe you don't get to teleport. Maybe you drop to the top of a 100-story building and fight your way down and enable a teleporter. And now you can do missions to that teleporter. And then the next goal is to unlock other teleporters nearby that then let you start missions from those teleporters. You know, something you could kind of picture that. And then there are occasional places where you can drop down and seed this process in various places in the city, and then expand out your zones of availability, and the zones eventually overlap because it is all one continuous city. The navigation mesh problem is pretty easy because you're constructing the building, so you can just build the navigation mesh while you're constructing the building. But you can also just use the voxels to determine if you say every voxel that's solid with say the voxels are 1 foot. So any voxel that's solid and has 6 open voxels above it, you can stand on it. And then that gives you a bunch of polygons, the upward facing polygons. And then you construct the nav mesh by connecting all those. But you can also just do that implicitly. You don't ever need to explicitly build that nav mesh. You can then just write your AI navigation to work from that data without explicitly building the nav mesh as a mesh. More questions? Doesn't have to be about this engine. Doesn't have to be about this game. So what's the plan? So as I said, we might just do voxels this week because now we've got this generator. It's too slow, and might just live with it being too slow because this is on old hardware. Actually, let's run X Sean purge games ZMC2 data debug ZMC2. I couldn't see it. I have to run it with X off 2560. There we go. This is it running on the streaming machine. So we can see that the streaming machine is a 4090. It's also doing all the streaming work, but you can see that the mesh time is much faster on a 4090. So that's 20, 40, 50, 55, 62. So, approaching 1 millisecond. Of course, we're doing this meshing every frame, and we won't need to build a mesh every frame. How fast? What's a fast walking speed? What's the athlete? And this is potentially slowed down a little bit by OBS even. The stream machine has a 4090. The Win 7 machine has a 980 Ti. Yeah, I programmed to an older card because there's no point in getting my performance optimized for a fast card. I want to optimize performance for a slow card because then the fast card is just guaranteed to be faster. If I optimized to the 4090, I wouldn't have done a lot of these optimizations probably because it wouldn't have seemed like we needed them. Now, as I mentioned this before, like if I needed to actually run the editor to build the maps and the 980 Ti is only 6 gigabytes and the 4090 is 24 gigabytes, so it can store a lot more map data in memory, or if just the editor is slow on the 980 Ti, then yeah, I would do all the map editing on the 4090. But while streaming and programming it, I'd still probably do it on the 980. But the 4090, like people don't have 4090s, right? Like some people have 4090s, but most people probably don't. So need to figure out like what's a fair low end thing to optimize for. And I happen to have an old 980 Ti in this, and the 980 Ti was high end for the 980. So, you know, but it's old. So, you know, that's the compromised machine that I happen to be choosing right now just because it's what's in here. But what was I saying? Uh, I don't remember what I was saying before I did that. I started to talk about something, but I don't remember what it was. We're talking about potential games. We talked about I don't remember. Maybe I wasn't starting to talk about something. At some point, I started to say, "What will we do this week?" Because I spent some time yesterday speeding everything up, and then today I spent the time slowing everything back down somehow, um, while adding these optional features that shouldn't have slowed it down. So I'm not quite sure what happened there, uh, but yeah. So I think what we do this week is now we ignore the speed issue. I mean, it's still fast, plenty fast, right? Like the it's bad that we spend 5 milliseconds a frame generating a mesh, because that will slow that one frame down, which means if you want to maintain 60 frames per second, if some frames it spends 5 milliseconds building the mesh, then you have to cap your other rendering to 10 milliseconds. But you might be able to spread it over multiple frames. Who knows? So we'll just ignore how slow it is since it's still plenty fast and start working on actually doing the procedural generation, because now we've got all these features. We've got the recolor retexturing features. Oh, walking speed. Yeah, size of the world. Yeah. Oh, right. Yeah, I wanted to think about how many do we need to generate, because based on the walking speed. So how fast is a person? This is something I often figure out and write down in places, but I don't know. Walk. Might be in 40-meter world. Walk, run. Nope. Maybe in a different file. Run. No. All right. Well, we'll just Google it. Athlete long distance run speed. So you could sprint. How long can you sprint though? $100 is 300 feet, so that's about one chunk. So like, what's a 200-meter sprint time? Is there such a thing? 250-meter? What is a good 300-meter runtime? Elite time. So because the idea is that you play your PC in a game often moves kind of fast. So I am approaching 60. years old. So an elite athlete, 300 meters in 30 seconds. So that averages out to 10 meters per second. Is that right? What's the 100-meter sprint time? Like, does that check out compared to the 100-meter? No, it's still 10 seconds for a 100-meter. So it seems a little implausible you'd get to 10 seconds at 300 meters. So, but okay, yeah, we'll just say that. So suppose you could run 300 meters sustained in 30 seconds. So that's 100 meters in 10 seconds, 10 meters per second. 10 meters is about 30 feet. So you're talking about 30 feet per second. So you need to generate chunks, maybe 10 chunks horizontally every time you move forward 256 feet. Yeah, this is basically an engine. So if what you can see horizontally, if what you can see in your distance is 10 chunks, you need to generate 10 chunks every time you move forward 256 feet. And to move forward 256 feet at 30 feet per second, takes 8 seconds. And during that time, you have to generate 10 chunks. So it's about 1 chunk a second is how much you need to generate. So we can spread that 1 chunk per second out. If we can spread that 1 chunk per second out, then the fact that it takes 5 milliseconds, if we can spread that 5 milliseconds over a whole second, right? Like we could run every stage. At a minimum, we can do each of these stages on a separate frame. But we really need to actually break these down and do them, only parts of them every frame. Then we can do that pretty well. And that's for 10 wide. If it were 20 wide, you'd have twice as many. So yeah. So I think we're okay with this amount of time being spent. We could actually be, this could be shippable timing. Like it's going to get worse because there's going to be more detail. So if it goes up to 5 or 10 milliseconds to generate, the fact that we don't actually need to do it every frame but only every once per second might make it tolerable. So yeah, yeah, exactly. So basically, if we have to generate a chunk every 1,000 milliseconds, then spending 10 milliseconds on it is probably fine. If we can spread that out over the frames. If we spent 100 milliseconds on it, then we're using up 10% of the GPU and stealing that from rendering, from drawing the scenes, and that might be a lot. It'll be better on a faster machine, because the faster machine needs to generate the exact same amount of data, maybe a little more because you have a larger viewing distance. But so it'll end up taking it'll run faster and therefore take up a smaller percentage of the total time. And therefore the worst case is the slowest machine, because they all have to generate the same amount of work except for the viewing distance thing. Yeah, exactly. Like one thing is, like we talked about this with the other engine, the terrain engine, where the terrain engine, everything lives on the GPU already, and you just can teleport instantly anywhere in the world. And as somebody pointed out, one thing that's good for is you can make very fast vehicles. You could put in a helicopter or an airplane, and there's no streaming, so it just goes instantly. So one thing about this engine is if you want to have a helicopter or a fast vehicle, then you suddenly start needing to generate chunks a lot faster. I think in the old engine for this, I actually had a design where there were these super highways high above the city, and you would potentially be able to ride in a vehicle on the super highways, but it would be a closed vehicle that doesn't have windows, and you would just like maybe it would generate like a fake version of the city that you could vaguely see through the windows or see on a map or something that didn't have the full detail. Free fall maximum speed is fine because the vertical speed doesn't matter because we're generating chunks on the XY plane, but covering the full height. Now, if you could turn your free fall maximum speed sideways, if you could, you know, bounce and suddenly be bouncing at a 90-degree angle, so now you were traveling horizontally at high speed, that would be different. Or like, the satisfactory tubes that shoot you real fast or whatever. Um, can you generate chunks with less detail when speed is high? It's unclear. Unclear how you would do that exactly. Like you could not generate the windows or something like that, but then the problem is then you stop and you need to rebuild them, and it's just like, fortunately there are no curved slopes in the voxel world, so don't have to worry about that case. All right. Let's final round of questions. So anyway, yeah. So this week, maybe we just work on trying to generate a real city, generate buildings, think about how to generate interiors, think about the road network, think about scale. Do we really want 1 foot voxels? Maybe they should be 1.5 foot. Maybe I should go back to 2 foot. Do you plan on streaming some of the optimization process? I already have. We've been doing optimization the whole time. There's no official time for when the streaming will happen because I don't keep a fixed schedule. Like yesterday, we streamed uh, in the morning. We did this command list culling parallel over list entries to speed up the culling phase. Going to implement a mechanism for shadows. So probably just use um, cascaded shadow maps for sunlight. Although I really kind of want to make the whole world just overcast and cloudy, like kind of a big fog, so that the distance limitation isn't obvious because we fog out to the distance, and therefore like the sun isn't visible because it's fogged. In which case you're kind of lit from all directions, and that's really ugly to shadow. Um, so I have a thought of sort of just a hacky way of computing. Basically, you need to know how much of the sky is visible. So I have thoughts for a hacky approximation for that. And then a thing we might do is it's a team game potentially. So you run around with a team, and uh, the team could have flashlights or lights on their guns or whatever, uh, and generate a little shadow map for each other player and show the lighting from their flashlights as well. That might be a nice thing to do. Maybe the idea there is that buildings are dark interior because the power is out. So the the rooms with windows bring in a tiny bit of light from the windows. Again, probably in a hacky way from the skylighting, and then all the other rooms are just pitch black, and uh, you would want those flashlights. And so we would need to figure out how to get if that efficient rendering. The nice thing about flashlights is, if you have a point light and you need to do shadow maps for it, you need to do shadow maps in 6 directions. You make a cube map. But if you have a flashlight, you only need to render a single thing from the viewpoint of the flashlight. And the narrower the flashlight is, the smaller resolution that can be. So you could have like 20 teammates and render 20 little things, as long as you can frustum cull that so that it's not generating. Because the problem is, if you have to render 20 million quads for each of those, that's still slow. So you need to be able to frustum cull that very tightly. Have you ever worked on some sort of fractal voxel engine where you zoom in each voxel would subdivide? No, I've never done anything like that. But this is all speculative. I don't actually know what the game design is. This is continuing. This is assuming that I continue with the game design from the original engine, which I don't know that I want to do. But if I did, that would be a thing to approach it with. And then the idea also would be that one of the mission types is that you turn on the power in the area. And now all the buildings will have lit interiors and play very differently. Maybe before you turn on the power, you don't have flashlights. And before you turn on the power, you can't really go into the buildings. Is the mic level low for anyone else? It's a little late to do that. Yeah, it is low. Yeah, the microphone got rotated, so the facing is not on the right side, but I have this thing covering it, and so I can't tell which way it's facing. The only marking that shows which way it's facing gets covered up by that. Now it should be a little bit better, but of course, the whole thing here is that like we played a bunch with this when we started the stream, and there was no optimal setting because sometimes I get loud. So like there, I was sitting back from it, and now I'm more facing it, so it's probably a little bit better, but still looks quiet on the settings. I could turn it up, but like I said, in the past, that's just caused problems. I tried to put a compressor on it, but it just made things worse. If your Twitch level is maxed and you still can't make it out and everyone else can hear it, well, that's a little low. That implies that you actually need to turn up your speakers or headphones or whatever method you have to actually listen. Like it may be on the quieter side, but it shouldn't be inaudible. All right, so that was the final round of questions. I'm looking back to see if I missed anything. With so many Windows apps using GPU acceleration for their rendering, how do we ensure the GPU is used at max for our own game? Tell people to close all the other apps. You were talking about the average GPU people have. I think Steam shows this. It's a little clumsy to make sense of because you can't really average them. You just find out what one's the most popular, but that doesn't really tell you the thing. And then if you look at the distribution, it's hard to really conclude much, because you need to be able to rank them and then find out what's the like 10th percentile or 90th percentile, I guess. All right. Anyway, I think we will stop there. That is, I first started saying about stopping 40 minutes ago. So, and then this week we will probably do some pretty regular streams and work on Gen. As I said, I want to stream all of the coding on this. So I might even stream every day if I feel like working on it every day. I getting some medical stuff tomorrow, so that might or might not interfere. We'll see. But yeah, maybe we might see streaming every day. We might not, depending on what I feel like doing. And maybe on Friday we'll do STB stuff. But yeah, the streaming is definitely working for what I wanted, which is to get me to program. So made a lot of progress here on 2 different projects when I hadn't done anything since Christmas, basically, before this. So, all right. Thanks, everybody. And I will see you next time.